Understanding regression is all about finding relationships in data. Regression is a statistical method that helps us understand the relationship between variables. Imagine we have data about ice cream sales and temperature. Regression can tell us how sales change as the temperature rises. This helps us make predictions about future sales based on the weather. Linear regression is a common type. It finds a straight line that best fits the data. This line can be used to make predictions. However, not all relationships are linear. That's where other types of regression, like logistic regression, come in. Logistic regression is a powerful tool in our statistical toolkit. Unlike linear regression, which predicts continuous values, logistic regression predicts categories. Imagine we want to predict whether a student will pass or fail an exam based on their study hours. This is a classification problem, perfect for logistic regression. Logistic regression gives us a probability. This probability indicates the likelihood of an event happening, like passing the exam. This probability falls between 0 and 1, representing certainty in either direction. The sigmoid function is at the heart of logistic regression. It takes any input and squashes it into a value between 0 and 1. This is crucial because we're dealing with probabilities. We need a way to translate our model's output into a probability score. The sigmoid function's shape is also important. It's an S shape, allowing for a smooth transition between low and high probabilities. This smooth transition helps us make more nuanced predictions compared to simply classifying things as yes or no. Section 5. A practical example. Predicting student success. Let's revisit our student exam example. We have data on students' study hours and whether they passed or failed the exam. We can use logistic regression to predict the probability of a new student passing based on their study hours. The model will learn a decision boundary that separates students who are likely to pass from those who are likely to fail. This information can help students understand their chances of success and adjust their study habits accordingly. Section 6. Training the model. Finding the best fit for our data. Training a logistic regression model involves finding the optimal parameters for our decision boundary. We use an algorithm called gradient descent to do this. Gradient descent starts with random parameters. It then iteratively adjusts these parameters to minimize the difference between predicted and actual outcomes. This difference is measured by a cost function. The goal is to find the parameters that result in the lowest possible cost. Once the model is trained, we can use it to make predictions on new, unseen data. Section 7. Conclusion. Key takeaways and applications of logistic regression. Logistic regression is a powerful tool for classification problems. It uses a sigmoid function to predict probabilities and a decision boundary to separate categories. Applications are vast, from spam detection to medical diagnosis. Understanding logistic regression empowers us to make sense of data and make informed decisions. Remember, logistic regression is just one tool in a data scientist's toolkit. Choosing the right tool depends on the specific problem at hand.